Hi everyone, I am Judaling Tila Bastida. Now that Alvin finished discussing about the meteorite, now let's proceed in the comets. So let us define first what is comets. Comets are celestial objects that have captivated the curiosity of astronomers and general public for centuries. With their brilliant tails and unpredictable appearances, comets have left lasting impressions in human history and scientific understanding. This report provides an overview of comets including the characteristic, the composition, formations, and significance in our solar system. How does comet start? Comets begin with their life in the Oort cloud, which is located beyond the planet Pluto. Here they begin as mixture of ice, rock, and gas. When one comet comes close to another, one of them can change direction and start their journey toward the sun. Comets are believed to originate from the outer regions of solar system, especially from region known as Oort cloud or Kuiper belt. The exact process by which comets is formed is not yet fully understood, but scientists have put forward a widely accepted theory called the nebular hypothesis. Let's tackle the characteristic of comets. Comets are icy bodies that orbit the sun in highly elongated and eccentric paths. They are often referred as dirty snowballs due to their composition of ice, dust, and small rocky particles. Comets typically consist of solid core known as nucleus, surrounded by a glowing coma and tail that points away from the sun. Parts of the comets. First, we have the nucleus. Nucleus, the solid core, comma, streams and dust and gas. Oil tail, ions sweep away from the solar wind. And last, we have the dust tail, dust particles illuminated by sun. Both tales provide valuable insights into compositions and dynamic of comets. The dust tails reveals the information, the size and density of the dust particles, while the ion tail provides the clues about the chemical compositions of the comet solar wind's interaction with it. Scientists study these tails to gain a deeper understanding of origins of our solar systems and the processes that shape celestial objects. Now let's proceed in the compositions. The nucleus of comets primarily composed of frozen water, along with the other volatile compounds such as carbon dioxide, methane, and ammonia. These ice are mixed with dust particles, organic molecules, and have a various mineral. When the comet approaches the sun, the heat causes the ice to vaporize, creating the ice, comma, and tails. I have there a short video clip.
What is the composition of most comets? Comets are frozen leftovers from the formation of the solar system composed of dust, rock, and ices. They range from a few miles to tens of miles wide, but as they orbit closer to the sun, they heat up and spew gases and dust into a glowing head that can be larger than a planet.
Now let's continue for the formations of comets. Comets are believed to originate from two main regions in our solar system, the belt and the Oort cloud. The Kuiper belt, located beyond the orbit of the Neptune, is a region populated by icy bodies. The Oort clouds, on the other hand, is vast and distant shield of comets surrounding by the solar system. Perturbations from gravitational interactions or passing stars can send comets from this reservoirs into inner solar system. Again, I have another video clip.
Comets are small icy objects that orbit the Sun. They have long tails and travel pretty fast. The majority of them travels between 10 and 70 kilometers a second. Most of the comets came from the cloud of dust surrounding the newborn Sun about 4.6 billion years ago, when the solar system had just begun to form. Much of the matter merged into planets, but some remained to form small chunks of frozen gas and dust about just a few kilometers across in the outer region of the solar system, where temperatures were cold enough to produce ice. Billions or maybe even trillions of them orbit our Sun far from the planets around an area called the Oort cloud. The Oort cloud is home to the majority of today's comets. This huge spherical cloud surrounds the solar system at a distance between 5,000 and 100,000 astronomical units. To get an idea of how far this is, Earth is just 1 astronomical unit away from the Sun. Sometimes, during stellar encounters, a number of Oort comets are sent flying. Some of them come really close to Earth or even collide with it. When a comet comes into the inner solar system, our Sun heats its ice and gas, forming a cloud around the comet's nucleus. Even though the nucleus may be only a few kilometers in size, the cloud, called a coma, can be thousands of kilometers across, even larger than Earth.
Now let's proceed in the anatomy of comet. First, we have the nucleus, the solid core of a comet, usually a few kilometers in diameter, is composed by volatile ice and rocky materials held together by the gravity. Next, we have the coma. As the comet approaches the Sun, the solar radiation heats up the nucleus, causing the ice to vaporize and release gases and dust. This creates a glowing coma and hazy envelope surrounding by the nucleus. Last, we have the tail. The solar wind and the radiation pressure push and release gases and dust away from the coma, forming a tail that points away from the Sun. Again, they have two tails. We have the ion tail and the dust tail.
Welcome to Inside Intrepid Education, a video series about exploring with history and science. My name is Alex, I'm an educator with the Intrepid Sea, Air and Space Museum, and today we're going to talk about the anatomy of a comet and what it means for space science and exploration. Comets are leftover remnants from the early days of the solar system. Most comets exist at the outer edges of the solar system in a place that we call the Oort cloud. Now sometimes comets will collide with each other. This will send one careening toward the Sun. When that happens, it becomes very bright in the sky and we can see it easily from the Earth. As the comet nears the Sun, it begins to glow brightly through a process that we call sublimation. Our experiment today is going to recreate that process for you. Comets are made up mostly of ice. Now this ice comes in two different forms. We have carbon dioxide ice, what's known as dry ice, and we also have water ice. Comets also contain rock and dust, which I'm going to simulate right here with some soil and rock I've got in a bottle. Comets also contain ammonia, methane, and other chemicals. So I'm going to simulate that by putting a little glass cleaner into my comet as well. Now the first step is to break our dry ice into very small powdery pieces. So cover up my ice, grab my trusty hammer. All right, we've smashed up our ice into a nice fine powder. Now it's time to mix the ingredients together. Now we're going to add our dirt and soil and rocky material. Comets have a good amount of dust and rock within them besides the ice. Now it's time to combine our ingredients. Take an ordinary plastic trash bag. A heavy-duty trash bag works best. Pour in my dirt. Always do the ice last. So next you want water, my ammonia, And finally, the dry ice. Make sure you get it all in, and then take the bag, close it, and using your gloved hands, compress all the ingredients together at the bottom. Oh, there it is. And there is my comet. The gas you see coming off of the comet is part of the process of sublimation. That is, a substance going straight from its solid phase into a gas phase without stopping at a liquid in between. The sublimating gases produce the tail of the comet that you see in the sky at night. One of the main reasons we study comets is because comets are suspected to have brought water to the planet Earth. And water, as we all know, is one of the key ingredients for life. So by recreating the anatomy of a comet, we've unlocked a piece of our own history. Thanks for watching. Keep experimenting and exploring, and please visit us at intrepidmuseum.org.
Now let's continue the significance. First, we have the origin of water. Comets are considered to be remnants from the early stage of a solar system formations. Studying comets provides insight into the origin of water and organic molecules on Earth. Number 2, we have the impact on Earth. Comets have played a role in shaping Earth history. Large comets colliding with our planet in the past may have caused mass extinction and influenced the evolution of life. Last, we have the exploration and discovery. Exploring comets help us to better understand the dynamic of our solar system and its formations. It also aids to unraveling the mysterious in other planetary systems. Comets are captivating celestial objects that offer glimpses into the early stage of our solar system formations. The study of comets provides valuable information about the origin of water, the dynamic of our solar system, and the potential impact of such objects on Earth. As technology advances, further explanation and research into comets will surely reveal more secrets about these enigmatic wonders of the cosmos.